My name's Yang Yo, and this talk will give you a brief introduction of our paper, UKPGAN, a general self-supervised keypoint detector. Keypoint has its great importance in computer vision, serving as a proxy for object matching, tracking, and retrieval. However, detecting 3D keypoints is still a challenging problem because of two fundamental difficulties. The first is the ambiguous keypoint definition. The semantics of keypoints is hard to tell, and many methods instead focus on the geometric features. Another is that, unlike 2D keypoint detector like Harris corners, we lack a universal keypoint detector that can be used on all scenarios in terms of various objects and downstream tasks. To solve the ambiguity of keypoint definition, we regard keypoint detection as information compression, in that one should be able to reconstruct the whole object with sparse keypoints. To achieve this, we propose the salient information distillation, where the point-wise embedding and keypoint probability get multiplied and squeezed out by the max operation. A single max operation does not guarantee sparsity, since the model could choose to maintain all the information, but still give a meaningful reconstruction. In order to force the model to learn a specific distribution of keypoints, we resort to GAN, such that the keypoint distribution would match our beta prior, with two parameters controlling the ratio of keypoints. We find that forcing 1/5 points to be keypoints gives a decent result. The whole pipeline is shown in the figure, where we take local rotation invariant pattern for each point as inputs and output both probability and embedding, with a reconstruction loss. It should be noted that during inference, whether a point is a key point only depends on its local neighborhoods, making it generalizable to real things. Notably, our model can be applied to both rigid and non-rigid objects, and generalizes well to real-world things. We first show a comparison of our model with previous ones on ShapeNet synthetic rigid models. Human annotations are from KeypointNet. It can be seen that our detector aligns better with human annotated ones, specifying those corners and important joints. Moreover, the rotation repeatability of our keypoint detector is almost 100%, thanks to the per-point rotation invariant feature extraction. For non-rigid objects, we give some results for SMPL human bodies, where we see that our keypoints are detected on the head and limbs, capturing the pose variance of human bodies. Besides synthetic dataset, we also apply our keypoint detector to real things by zero-shot sim-to-real transfer. Our model is able to detect those salient keypoints and could improve the current geometric registration results. Thanks for listening. More results and code are available on our project site.